All right, in the last video, we talked about a few properties of logarithms. In this one, what I'm going to do is just take you through a bunch of examples. So we're actually going to be looking at this right here, this sheet. And if you need to, pause the video and write some problems down before you actually give them a try. Let's see if we can focus there. There we go. And I'm going to take you through all 21 of these where we are writing them as a single expression, or another way to say that is to condense the logarithm. And then I'm going to take you through these right here where we're going to expand the logarithms. So they're already condensed and we're actually working back to what we've seen up here. So we can go backwards or forwards with our properties here and still get this equivalent expressions. So sometimes in a problem we want to condense them, sometimes we want to expand them, whenever we're solving. Now I'm not going to take you through in this video on the change of base because I feel like for right now that's not necessary, and there's 30 problems here. That's going to make this video pretty long as it is. I went through a couple of these in the last video, but I'm going to start over as if you didn't watch that video because maybe some of you didn't. Go ahead now, pause the video, give some of these a try, and then come back and see how you did. All right, I take it that you've attempted those. If you couldn't and you just didn't know where to start, maybe you should go back and watch my video on properties of logarithms. I'll give you a hint. It starts off with me talking a lot about bacon, all right? So watch that and then come back and try these. Otherwise, let's get to it. So this first one right here is the log base 5 of 4 plus the log base 5 of 3. That's what I'm going to work out. And we know that with logarithms that we have some properties that we can go through. In fact, let's go ahead and write those down. Again, we've got the log of a plus the log of b is equal to the log of a times b. We also have the log of a minus the log of b equals the log of a over b. And then we went through one where we said, you know what, if you're taking the log of a raised to the power of b, you can rewrite that b out front in front of the logarithm. That exponent can be moved right there, and that equals b times the log of a. Now, all of these I wrote in base 10. You can write these in any base. So it could be base 4, base 3, it could be base e, and just write it as natural log if you want to. We'll probably see some of that at some point. But these are our properties that we're going to be referring to the whole time today. And this is our first one right here. It's base 5. It's log base 5 of 4 plus the log base 5 of 3. And we can say that is the same thing as taking the log base 5 of 4 times 3. Well, 4 times 3 is 12. Bam, there's number 2 right there, right? So we've got log base 6 of 25 minus log base 6 of 5. That goes back to the second property we talked about. If you got a subtraction symbol, you can write it as a single logarithm with the first one over the second one there, so a over b. And that's what I've got here. Log base 6 of 25 minus log base 6 of 5. I can rewrite that as the log base 6, get the right base in there, of 25 over 5. But I can simplify 25 over 5. That is the same thing as log base 6 of 5. There's my answer for number 2. Let's box in the answer to number 1 right there. And boom, there's number 3. So with number 3, notice we've got 3 different terms here. And I'm going to follow order of operations, which says to add and subtract from left to right. So I'm adding first when I go left to right here. And that's what I'm going to combine first. Now, these are all base 2. So I can combine them all, but when I do, it better be log base 2 still. And so I've got 4 plus 2, not 4 plus 2, but the log base 2 of 4 plus the log base 2 of 2. So that means I'm going to multiply 4 and 2. 4 times 2 is 8, so that's the same thing as log base 2 of 8. And then I'm going to bring down this minus log base 2 of 8. And then I can combine these. This becomes, let's see here, I've got a subtraction symbol here. I can write that as the log base 2 of 8 divided by 8. And that equals the log base 2 of 1, doesn't it? Now, we haven't talked about this yet, in my class at least, but some of you may know that the log base 2 of 1 is really asking 2 raised to what power equals 1. So what can I raise 2 to what power equals the number 1? Well, that's a 0. And so we're going to learn later on that this is the same thing as 0. Now, if you're in my class and we haven't talked about this, I will take that as an answer. I don't know in what year you're watching this video, so talk to me if you have a question on what you want for an answer, what I want for an answer. Let's look at number 4. There's number 4, and we once again condense this to a single logarithm if we can. I'm going to take this 5, and I'm going to move it as my exponent right there. And I'm going to take this 2 right here and move it as my exponent to that x right there. That is taking this third property we wrote down into account. We can say move that b up here to the power spot. So this becomes log base 7 of x raised to the 5th power minus log base 7 of x raised to the 2nd power. And now because of that minus sign is in between there, and they are logarithms of the same base, I can combine the two logs. So that's going to give me log base 7 of, this number goes first, x to the 5th divided by x squared. And then going back to algebra, remember when you have x to the 5th being divided by x squared, we're going to subtract the exponents, and I get log base 7 of x cubed. That's my logarithm there. All right, on to number 5. So for this one, once again, follow order of operations. I'm going to go left to right. I come across a minus sign first, and I can say this is log base 4. They're both base 4, so that's important, of 60 divided by 4. And then we've got plus log base 4 of x right there. 60 over 4 is the same thing as 15, so I could write it like this. That makes it a little bit easier to look at. And then because of the plus symbol, I can write this as a single logarithm. Once again, they're both base 4, so I can combine them, of 15 times x here. And this is my answer for number 5. Number 6. We got number 6 right here. Notice, what is the base to this logarithm? Well, there's not one written down. That means it must be 10. So that's just something to keep in mind if no base is written. The base is 10 there. So we've got log base 7 minus log base 3. Let's combine that first. We're following order of operations, addition and subtraction from left to right. So I get log of 7 over 3. And then bring down that log of 6. Once again, we can multiply these two and make it a single logarithm. 7 over 3 times 6. I'm going to go ahead and make it a fraction because we can easily combine that, or not combine it, but multiply it. So 6 over 3 is the same thing as 2, right? And then we're going to say 7 times 2 is 14. This simplifies to the log base 10 of 14. All right, let's look at number 7. Here's our number 7, and so we've got 2 log x minus 3 log y. Let's go ahead and get these exponents going first, so that gets moved up front, doesn't it? And so this gives me the log of x squared minus the log of y cubed. And because of that minus sign, we can now make this a division problem, or at least the log of two things being divided. We say this is the log, this one goes first here, of x squared over y cubed. And that's as far as we can take that one. Now, one interesting thing to note on this is some students look at this problem like this. They say, all right, we've got 2 log x minus 3 log y. And this is how they approach the problem. They might say, move the 2 up top, and they move the negative 3 up top. So this would be the same thing as log x squared plus log of y to the negative 3. And then when we add these, we're going to be multiplying them to combine them. So we got log of x squared times y to the negative 3. Well, what is y to the negative 3? Well, y to the negative 3 is the same thing as saying 1 over y cubed, isn't it? So even if you went this route, you could say x squared times 1 over y cubed, which is the same thing here that we got. Now, I don't really think it's beneficial to do it this way. It looks like more work. But if your question is, can we do it that way? Yeah, technically it would work. But I think it's much more efficient to leave that negative there, that minus sign there, and it keeps you from making any silly mistakes. So if you're going to go that second route, I want you to rethink it. It doesn't hurt if you can keep up with it, but I prefer you not make any silly mistakes. On to number 8. Once again, number 8, we're going to say, I got these numbers out front, move them in here as exponents. And so that gives me log of r to the 1/2 plus log of s to the 1/3 minus log of t to the 1/4. Now, one thing we can do is we know that anything raised to the power of 1/2 is the same thing as the square root. So you could be looking at it like this. Anything raised to the 1/3 is the same thing as cubic root. So we have the cubic root of s here, and then we could say that this is the 4th root, so we could say the 4th root of t. For me, I really don't care if you leave it as an exponent or if you write it as a radical in this case. Sometimes we will need to switch between fractional exponents and radicals when we're doing our work. From that point, don't forget the plus sign right there, I can say, all right, I can combine these two using multiplication. So I get the log of square root r times the cubic root of s. I can't combine these even though they're both radicals. One's a square root and one's a cubic root. That's as far as I can go with that. And then 4th root of t over here stuck on the end. And then lastly, to combine these, I'm going to say, all right, I've got a subtraction symbol there, so I've got the same base, log base 10. And in the numerator, we're going to have square root of r times the cubic root of s. And in the denominator, we're going to put the 4th root of t. Okay? Once again, this is all good practice, just trying to combine and expand our properties. Right now, it's all combining. But once we get through these first 21, we'll be expanding some as well. Okay? This one, once again, all the logarithms are the same base. Always good to check for that, especially when we get into solving equations of logarithms. But they're the same base, so I'm going to do some combining here. We've got the log base 3 of 4x. Let me make sure I copy that right. Yep, that looks good. Log base 3 of 4x plus 2 log base 3 of 5y. First thing I note is, hey, that number's out front. I can move it and let it become the exponent of whatever that I'm taking the logarithm of right here. So it's going to be 5y raised to the power of 2 there, and that's log base 3. The next thing I can do is, because of that plus symbol, I can combine these using multiplication. So I've got the log base 3 of 4x times 5y quantity squared there. I can clean this up a little bit more. 5 squared is 25, and y squared is y squared. And then 4 times 25 is 100. So I get 100x y squared and log base 3 of that. This one, once again, we got numbers out front. Let's move those numbers out front into the exponent spot, and I get log base 10 of 2 to the 5th minus log base 10 of 2 to the 2nd here. Continue to combine these. I can do the log base 10 of 2 to the 5th up top, divided by the log, not the log, but 2 squared there. Yes, you could say, what is 2 to the 5th and calculate it out, and what is 2 squared and calculate it out? It's much easier, though, to use our properties of exponent that we learned in algebra, right? And say, if I've got something raised to the 5th being divided by that same something raised to the 2nd, I can subtract the exponents. And we're going to learn how later on how those are actually tied into these logarithmic properties that we're discussing today. So 2 to the 5th over 2 squared is like saying 2 cubed. Just a side note, if you're wondering, like, how does that work out? Remember, 2 to the 5th is the same thing as 2 written down 5 times and multiplied. And 2 squared is the same thing as 2 written down twice and multiplied. So these two right here cancel out these two, and you're left with 2 cubed. That's how that works. So this is log base 10 of 2 cubed. That's number 10. My hand's getting all marked up here, isn't it? This is number 11. Now, the interesting thing about number 11 is notice what we're taking the log of is the exact same thing. So we have 1/3 of this mess plus 2/3 of the same mess. So 1/3 plus 2/3 is 3/3. So really I can just add this up and get 3/3 of log base 10 of 3x, which is the same thing as log of 3x. That's my answer. And you say, that's not fair, you didn't teach us that. Well, let's look at what I did teach you. What if you went through that process there and said, you know what, I'm going to start off by moving that up top and move this up top. So what we would get is the log of 3x raised to the 1/3 plus the log of 3x raised to the 2/3. And then you go through this process right here. You say, that's the same thing as the log of 3x raised to the 1/3 times 3x raised to the 2/3. And then what happens when we multiply the same base raised to different exponents, or even just any exponent? We can add the exponent. So 1/3 plus 2/3 becomes 3/3 like this. And 3/3 is the same thing as 1. So it's like saying log of 3x raised to the first power, which is log of 3x. That's a longer route to get to the same answer we got just by noticing, like, hey, I've got 1/3 of something right here plus 2/3 of that same something. These things were the same, so that's why we could just add the number out front there. Okay? So that's number 11. So when we look at number 12 here, we kind of see, like, just like number 11, hey, I've got the log of something, log base 10 of 2, plus the log base 10 of 2. So I've got 2 of those. So I can just say, hey, that's the same thing as saying 2 log base 10 of 2. So I'm just combining those up. And I've got 2 log base 10 of 4 right here with a plus sign in between. And now I can go ahead and say, I can't combine those two, notice, because I'm taking the log of 4 here and the log of 2 there. So those are different things. These were the same, so I just combined them. And I jumped to that because everything's being added here. There's, addition's commutative. So looking at this right here, I can take this 2 and move it up top. And that gives me the log base 10 of 4 squared plus, let's go and move that up top too. Why not? And we get log base 10 of 2 squared. So that's log of 16 plus log of 4. And I can combine that. Because of the plus symbol, I can make it the log of 16 times 4, which is 64. So the log base 10 of 64 is my answer for number 11. Nope, not number 11, number 12. All right, on to number 13. So number 13, we got the log base 10 of 3 minus log base 10 of 4. I'm going to combine that and make the log of 3 over 4. And then bring down this one over here. And let's go ahead and say that's the same thing as the log of 3/4 divided by 2. And we can make that a fraction on the bottom. We're going to keep it, switch it to multiplication, and flip this to 1/2. That gives us 3 over 8. So this is the same thing as 3 over 8. But don't forget, we're taking the log base 10 of that mess. And so that's our answer there. All right, let's look at number 14 now. So number 14, we've got to move these up top. Oh, we got something already there, don't we? Let's see what we get. We get the log of x raised to the 5th plus the log of x squared, the whole thing raised to the 3rd power. Remember that when we take an exponent raised to a power, we multiply those two. Why? Because x squared cubed is the same thing as x squared times x squared times x squared, right? And then we just add those up. We get x to the 6th, which is the same thing as multiplying those two numbers. So this is the same thing as the log of x to the 6th plus the log of x to the 5th. And I can combine those and make it the log of x to the 5th times x to the 6th. And remember, once again, we just add those exponents and you get the log of x to the 11th. Okay? Let's look at number 15. So for number 15, I've got same basis, base 6. And so I can combine that and make that the log base 6 of 3 over 6, which is the log base 6 of 1/2. So this one, we got log of 2 plus the log of 4 minus the log of 7. Combine these two right here. This gives me the log of 2 times 4, which is 8. And then bring down that log of 7. And then we can say this is the log of 8 over 7. That's my answer for number 16. Number 17. Number 17 says log base 3 of 2x minus 5 times log base 3 of y. Let's move that 5 up top here. And we get y to the 5th. And we've got log base 3 of 2x right there with the minus sign. Go ahead and treat this as a division problem when we combine them. So log base 3 of 2x over y to the 5th. That's as far as I can take that one right there. Number 18. So 18, we can work it a couple ways. You could distribute the 1/3 and go from there. I'm actually just going to work inside the parentheses first and combine those two. So this becomes the log base 2 of x divided by y. And then I'm multiplying that by 1/3. So I can take that 1/3 and move it to the top here. Now it's not just the x being raised to the exponent, it's the whole fraction there. So when I rewrite it, I'm going to say the log base 2 of x over y, and the whole thing is raised to the 1/3. That's my answer for that one. Notice, had I distributed it up top, then it would have been 1/3 right here and 1/3 right there, and then I'd have to move that 1/3 to right here, and then move it also, this one right here, where 1/3 would have been right there. And so you would have ended up with x to the 3rd over y to the 3rd, or you could say the whole thing is being raised to the power of 1/3 there. All right, number 19. So number 19, I'm going to have that same approach where I say, you know what, 1/2 gets raised to the top, 1/3 gets raised to the top, and 2 gets raised to the top there. Let's see what that looks like. Log of x to the 1/2 plus log of y to the 3rd minus log of z squared. These two have a plus sign in between, and we're doing order of operations going left to right. So that is the same thing as log of x to the 1/2 times y to the 1/3 minus log of z squared. And then I'm going to combine these two right here using that subtraction property and say I've got the log of x to the 1/2 times y to the 3rd all over z squared. And if you wanted to, you could have written this as square root of x times the cubic root of y all over z squared with a log in front. I'll take either as an answer, okay? So that or the one below it. For number 20, we're going to say, okay, let's distribute that 3, and I get 12 times the log of t squared. And then I'm going to move this 12 up top. And so I get the log of t squared raised to the 12th power. And remember, we can multiply those two to simplify it, and we get the log of t to the 24th power. Number 21. For number 21, let's see what we've got going on. We've got this log base 5 of y minus 4 times this mess. Well, once again, I'm going to go through and just combine what's in the parentheses first because I can. And so we've got log of 5, and don't forget that needs to get moved up top. So the log base 5 of r times t squared. Just the t is squared there because it got moved up top. And it's still being multiplied by -4 here. So when I multiply by -4, remember, I can move now the -4 to the top of this mess right there. So all of that's being raised to the power of -4. And write the logarithm like this. The log base 5 of rt squared raised to the 4th power. which becomes, I can distribute, you can think of it as distributing 4 times r to the, or to the 1 right there. 4 times 1 is 4, and 4 times 2 is 8. So I went through all of, let's highlight it in blue, everything in blue up top right here became this down below. We don't, sometimes it's easy to say, boom, there's my answer, but we're only partway through the problem, aren't we? We still have a minus sign in front of this, and don't forget all of that right here needs to come down. So we've got log base 5 of y in here. And so now I got log base 5 of something minus log base 5 of all that mess, and I can combine it and say this is the same thing as log base 5 of y over r to the 4th and t to the 8th power. Hey, if you've made it this far, congrats to you. We're now done with condensing the logarithms. All right, I know there's a lot of problems there, 21 of them. Hopefully you just went through, maybe saw my answer key and just said, I'm going to skip around in the video and find the one I need help with. If you didn't and you watched all 21, good for you. If you're following along and you're at least getting the majority of those correct, you're well on your way of being very comfortable with working the properties of logarithms. Now we're going to take a look at the next section on the worksheet here, and we're going to expand logarithms. So we're still using these properties right here that we learned in that first section, but instead of going from here to here, we're going to be working backwards. So the directions on this say to expand each logarithm and simplify if possible. So that's what we're going to do, are these 9 problems. We're going to work through those, and then we're going to call it a day, or at least, I don't know, maybe you're cramming for an exam and you're not calling it a day, and you're saying, I'm going to go on to the next video, which is fine. This, though, is number 22, and we are going to expand this. So I notice I'm taking the log base 10 of x, y, z, and if it's being multiplied, I can expand that out using plus symbols. All the logarithms here must be written with the same base, which they are. They're base 10. And so I'm going to say this is the same thing as saying log base x plus log base y plus log base z. And just like that, that's as far as I can take that one. Let's now look at this one right here. This says the log base 2 of x divided by y over z. Well, I'm going to first address this division part and say this can be written as log base 2 of x, the top number, minus log base 2 of yz. Don't leave the problem right here because it can still be expanded. That right side there is y times z. I can write this as, keep the same thing right here, log base 2 of x minus log base 2 of y plus log base 2 of z. Now it's completely expanded, and I cannot expand it any further than that. Let's look at number 24. 24, it's log base 10, and I've got 3 numbers being multiplied. I'm going to split that up first. Notice I don't want to pull this 3 out front because that's saying that 6 is cubed and so is y, but it's not, just the x is cubed. So first I'm going to split it up like this, log base 6 plus log, not log base 6, but log base 10 of 6 plus log of x cubed plus log of y. And then I can move this 3 up front, and you have to move it up front if we are going to be completely expanding it like I want you to on the test. So we get this right here. And boom, it's done. Number 25. So number 25, I've got this 7 out front, and then I've got 3x minus 2 quantity squared in here. And I want to expand this completely. So look at this 7 as a number, and then look at what I'm boxing in here as a separate number. Because that 7's not being squared. That 3x minus 2 is. If I do it that way, I can say the log of 7 plus the log of 3x minus 2 quantity squared. And notice everything in here is being squared, so in this case I can move the 2 out front. So the log of 7 plus 2 log of 3x minus 2 in here. Now this is not, don't get it confused with when we're dividing and we can separate them using subtraction. I can't do that in here. This is saying log of 3x minus 2, and I'm stuck there. All right, so that's where I'm going to stop here, and that's the answer to number 25. All right, 26, I'm going to rewrite this radical as an exponent just because it will make life somewhat easier. We've got 2rst over 5w. This is the same thing as, square rooting all this mess right here is the same thing as raising it to the 1/2. So that's what I'm going to do right there. And there's a couple of ways we can look at this. We can go ahead and move out the 1/2 out front if we want, or we can say it's the numerator raised to the 1/2 and the denominator raised to the 1/2. I'm going to move it out front already. So that gives me 1/2 of the log 2rst over 5w. Now anything else I write here, it needs to be 1/2 log something, because I'm going to split this up even further. So splitting up even further, I'm going to take 1/2 log the numerator 2rst minus 1/2 log the denominator 5w. Now all of this I can break up like crazy, can't I? It's just 4 numbers being multiplied. So I can say 1/2 log of 2 plus 1/2 log of r plus 1/2 log of s plus 1/2 log of t minus 1/2 log of 5 plus, because I'm going to split this up, 1/2 log of w. And here, if you're on a quiz, don't do that to me. Let's write it out a little bit better. Plus 1/2 log of w. Now, it's acceptable to write it like this. This is what, number 26. I would have been just as happy if you would have written 1/2 right here. And then inside, instead of writing out 1/2 each time like this, you could have written it like this. 1/2 log 2 plus log r plus log of s plus log t minus log of 5 plus log of w. So putting that 1/2 on the outside, I still managed to run out of space here. That would have been fine. I know you're going to distribute it to each one of those terms to get it to look like that right there. If it's on a test or quiz, I'm writing this kind of quickly to get through the video and with a marker so it smudges easier. You should be using a pencil and write it out neatly. So I don't want to have to try to guess, because I'm not going to guess what you're writing down on a quiz or a test. I want you to make it nice and neat for me, please. And if you need extra paper, let me know, because some of these get to be pretty lengthy, don't they? Let's look at number 27. 27, we've got the log of 5x over 4y. So I'm going to rewrite this as the log of 5x minus the log of 4y. And then I can split that up. So take care of that division part first. And then we can say the log of 5 plus the log of x minus the log of, what do we got here? 4 plus the log of y. And it's important to note something here. If we're doing this, so we want to make sure it's careful, it might not be a bad idea to wrap this in parentheses. So that way we know to combine this first and then worry about that subtraction symbol here. Otherwise, doing order of operations is easy to skip over that part right there. Okay? In fact, you could even write it, distribute it, if you wanted to. You could distribute that negative and make it look like so. And then you won't get it wrong. Because if you don't put that parentheses here, or if you don't distribute that negative, it's not the same problem. All right? Because what I'm going to do, let's suppose you didn't write the parentheses here. This is the way I'm looking at it. If I'm combining it, I say, okay, order of operations, combine those first, and you get log of 5x. And then I'm going to say, take this, and that becomes over 4. And then I'm going to see that plus symbol there, and I'm going to say, okay, times it by a y, and this is what I'm going to get if you don't wrap it in parentheses, which is not the original. That y moved up top. So make sure you're very careful here. We are dividing by 4y. So wrap it in parentheses. If you want, you can distribute the negative, or you can leave it wrapped in parentheses. I'm fine with that too. All right, so this is my answer right here. Or this right here wrapped in parentheses. This is what you don't want to end up with. Number 28. So 28 looks like that. Notice that it's the x being raised to the negative fifth power, not the 5. So I can go ahead and split this up and say log base 5 of 5 plus log base 5 of x to the negative 5. Then we can move the negative 5 out front, and I get log base 5 of 5 plus a negative 5 log base 5 of x. Now, once again, if we've reached the point in the class where we talked about what logarithms are, what this is an easy one we can reduce here. It's saying 5 raised to what power, same base, 5 raised to what power equals 5? And the answer is 1. So I say that's easy because if you recognize that, you say, hey, that's the same thing. Log base 5 of 5 is the same thing as 1. And then we can subtract from it 5 log base 5 of x here and get this for our answer. Once again, if you don't know that, because I haven't taught it to you yet, I'm perfectly fine with you leaving that as your answer also. All right, 2 more left. Let's get it going. Number 29, I'm going to go ahead and split this up. Remember, take care of that fraction first. We've got the log of 2x squared y minus the log of 3k, 3. And so from here, I'm going to split this one on up. And I'm going to say the log of 2 plus the log of x squared plus the log of y. And I'm going to throw this 2 out front. And so I get the log of 2 plus 2 log x plus the log of y. So that takes care of the left half right there. And then I need to subtract all this. If it helps, remember that last problem we said wrap it in parentheses. You can go ahead and do that from the get-go. And maybe you won't forget to do that later on. And I'm going to do this side over here in blue just so it doesn't get all jumbled up with the work we've already done. So if it helps you, we can draw a line there, but don't forget, it's all going to get put back together. So I'm going to split this up and say this is the log of 3 plus the log of k cubed. And don't forget, this is all in parentheses, and we get a minus sign out front there. And drew that line, I can't put it in there now, but there's a minus sign right there. And then I can expand this and say we've got the minus, let's see here, the log of 3 plus, move that 3 out front, 3 log k. So I need this and this to be combined. And so I'm just going to write it all out as my final answer in black. I've got log of 2 plus 2 log x plus the log of y minus, in parentheses, the log of 3 plus 3 log k. And if we're simplifying it, we throw that negative in there. So one more time, who doesn't like writing this stuff over and over again? Distribute that negative, we get minus log 3 minus 3 log k. And boom, there's our answer. Lots of logs there. One more, number 30. So for number 30, I'm going to go ahead and move that 2 out front because everything's wrapped in it. So let's move it out front. We get 2 log base 4 of 3xyz. And if it makes you happy, you can go ahead and wrap this part in parentheses. We don't have to keep writing 2 log base 4, 2 log base 4, 2 log base 4. That's annoying, right? So we'll just leave that wrapped in parentheses, and I'm going to expand all of that and say we got log 4 of 3 plus log 4 of x plus log 4 of y plus log 4 of z. And so that 2, you could write it out with each one. I don't care. You know what? I know it's the last problem. You're ready to quit, but I am going to write it a little bit neater because I wouldn't be happy if I was grading that. So log base 4 of 3 plus log base 4 of x plus log base 4 of y plus log base 4 of z. There we go. And like I said, you could distribute the 2, and I'll take that as a correct answer if you have a 2 in front of each one of those, or you can leave the 2 on the outside. I'm happy with that also. Wow, that is 30 problems right there done for you. Once again, congratulations if you've done all 30, especially in one sitting. I mean, we're at 40-minute mark right now. So thank you for watching. Please let me know if you have questions, and please make sure that you understand these properties and how we can expand logarithms and how we can condense them, because we will be using those as we work with logarithms this year. Okay? Thanks for working hard. I know you're working really hard to go through all these problems, and thanks for watching. I'll see you next time.